Hi everyone, welcome back to another episode of D4 Data Channel podcast. I'm your host Deepak, and with me we have Mr. Lakshminarayan and Mr. Harpreet. So both of them are from Thomson Reuters Lab, and they are actually working a lot in this domain of ML ops and machine learning products into practice or implementation side. So today we are actually focusing a lot on the ML ops perspective and how to build a data science product in its full structure or in that exact procedure as how the MLOps is actually suggesting. So before starting, I would like to give a big thanks to Miss Shirsha Ray Chaudhuri for coordinating and scheduling all these podcasts from the Thomson Reuters side. And big thanks to Miss Shirsha. So without further ado, we can get started with the MLOps. So yeah, first I would like to give a small intro about the whole idea of MLOps. So, like right now, like nowadays, you will be hearing a lot about MLOps, and it's kind of like a buzzword right now. So, what exactly happens is like in traditional software data cycle or in software machine learning cycle or what happens is like there are complications when a data science model or a series of data science models is actually put into implementation. So that's where all of these new technologies or new way of working evolved, and right now we have something called a very concrete structure called MLOps, which deals with most of the pipeline in an entire machine learning sequence. So that's what we are kind of giving an understanding and overview on how to effectively put all of these things into practice. So I would like to start my questions on MLOps. So my first question is like, so model creation is the main part, or like it's an important component in that entire uh, sequence actually. So for model creation, which tools and frameworks are normally recommended in an MLOps perspective?
I think, yeah. So I'll mainly focus on the NLP side of things, right? So in NLP, we use the commonly used frameworks that I use are Hugging Face, of course, because that's the most popular and a lot of the latest, algorithms are being implemented there. And apart from Hugging Face, we use Fastix quite often because it's a very lightweight framework. So the models that it generates, though, are quite powerful, but they're very lightweight and easy to deploy. And on top of that, we also use OpenNMT. And though it's a bit of an old framework, you can say, given the pace at which NLP frameworks are being developed. And also we use scikit-learn because it offers some tokenization and classical machine learning techniques like random forest, boosted trace, and so on. These are the commonly used frameworks that we currently use for NLP machine learning. And another important aspect of this, right? So it's once you all develop the model, it's also how we kind of deliver that machine learning inference, right? So to do that, one commonly used technique is to use Docker images. So what we do is we create like a package of the whole inference module, and that's containerized within like Docker image with its dependencies and so on. And here also there are challenges involved associated with that. Things like how to optimize the Docker image, how to scalability and so on. Because while deploying, a lot of these things are very important, right? So if you have very bulky models, then the latencies will be high, and if you're using like serverless frameworks and so on, the cold start. So there are a lot of optimization that goes after the model is developed, like reducing the model quantization, reducing the model size, optimizing the model code as well. Like so, sometimes, for instance, I can give an example. So Hugging Face has this tokenizer, right? So it's also implemented within the transformers library, but there's a separate tokenizer library which is much faster. So if you, even though while developing the model you can use the tokenizer that's part of the transformers library, if you instead use the tokenizer that's coming from the tokenizer library, which I believe is written in Rust, the backend of which, so that's much faster. It's a much lightweight library as well. So these are some of the optimizations that also go into the whole model building, model development stage.
Great. Great. So basically, it's like once the model is built, it is exposed as an inference API, and then it is Dockerized. So the entire script will be Dockerized, and inside that script, this inference API will be called, so that we are not directly loading or downloading the model in the runtime. Perfect, perfect. And when you said about optimization, like it comes with code running and maybe even the file extension also. I think like the file extension of this TensorFlow and PyTorch can also impact in terms of the performance, as you mentioned. And even the so regarding the model size and pruning, so like is there any trade-off which you guys are actually performing while like based on the model size and the accuracy perspective, is there any kind of a trade-off which is happening?
Yes. So normally, what happens is the business has some kind of minimum accuracy that is worthwhile, right, from point of view of business value. But our models will obviously try to, when building the model, will also try to get the maximum accuracy possible. So we have some leeway so that even if the accuracy drops a bit by maybe, say, from zero point 0.9, it drops to 0.85, right? It may not be too much from impacting the business point of view, but we could reduce the model size a lot by giving up that much of accuracy. So that is a trade-off. It's a very subjective decision. It depends on the use case. It depends. It's mainly driven by the business use case, right? Some cases we need very high accuracy, so you don't have that bandwidth at all to optimize on the model size and so that and give up on the accuracy. Because usually when you do this quantization, you will be giving up some amount of accuracy, but it's an experiment. So we do this. So most libraries have a quantization inbuilt in them, like FastText has its own quantization, and there are other things that other libraries like ONNX which allow for some quantization and so on. So all of these libraries have quantization inbuilt, but we need to experiment with the parameters of the quantization, like the floating point accuracy and things like that, and see how much of an impact you get on the performance of the model. And that's a trade-off that we have to make. It's a subjective decision.
Great, great, true, true, I agree to that. And going on to the next point, so once we have the model or once we have the code ready, like we have to deploy it in, or we have to actually make use of different cloud services. So like while in this MLOps space, like which cloud services are actually being used for your purpose or for the entire sequence basically?
Yeah. So, in the ML landscape, there are a lot of cloud services which are used at various stages, like be it model building, development, training, and deployment. One of the major services that we use is AWS SageMaker, which brings us a broad set of capabilities required for end-to-end lifecycle, not only for training and deployment, but also for building. So, if we talk about build and train process, then SageMaker Notebook is a one-step SageMaker Notebook. We can directly trigger it from that. Then we have the SageMaker training jobs which are used. And because these jobs require data, so S3 comes into picture. So S3 is an object storage with an industry-leading scalability and data availability. So once this building process is done, so we to have a true MLOps type of picture, we can say that we need to have a continuous building and training deployment system, which is in some known as CI/CD for ML. For the CI/CD to work, you need to have a standard code base. It can be GitHub, it can be what do you call it, Bitbucket, or maybe GitLab too. So once you have standard code base where you can avoid all the things, then you need a solution which is like, for example, if you push a code to Git repository, automatically should build and deploy, and it should happen automatically. For this in AWS, we have AWS Code Build services and the Code Pipeline service. So this CI/CD is taken care of, but what about the infrastructure? That because this whole thing requires an infrastructure. So how we automate and create a provision of infrastructure. So this thing is taken care by CloudFormation. CloudFormation or SAM also. So this is a simple. We write the infrastructure, the code type of concept in simple YAML language, which creates which automatically provisions the infrastructure. So whenever it is required. So let's suppose that it has to be deployed. So whatever the infrastructure that is required, it will be automatically provisioned whenever the deployment has to be happened. Now coming to the model registry part, we need to store the models and versioning all those things. So in AWS, we have the Elastic ECR, Elastic Container Registry, which acts as a model registry, which along with the versioning, and if we need to have to store model artifacts, then it basically it's done in an S3 as it can be done. Coming to the last part, like the model deployment part, I would say the choice of cloud services basically depends upon like what is your use case and what type of requirements you have. Like for example, as Lakshmi wrote, it's a latency requirement, and you don't have a big size model, you can directly go with Lambda as a server solution, which could be good for deployments of small models. But if you have a use case where your models based solution requires a GPU or high density cores, then SameWaker endpoints can be used. So this is completely based upon the deployment. So they can be coupled with API gateway to serve traffic to as endpoints to that. So yeah, on a broader level, the MLOps lifecycle, these are the services that are used in MLOps.
Got it, got it. So that covers the entire cycle actually. So, like a couple of questions here. Like, so on the model training aspect, like, so when we are kind of getting that requirement and when we are getting that data, so like, while training part, like how this kind of data or where that data is actually sitting while actually training this entire pipeline, is it in the same cloud or like is it being in some shared service basically?
Yeah, it's in the same cloud. So that thing also makes that is the major thing. That is why we are considering cloud as a cloud provider. That thing's a major thing because with data, to training data, there's a lot of other things that we need to take care of, data security and data privacy, all those things. So, and along with that, we need to have a solution that is scalable as well as having good availability. So, data stores in a job storage. In our case, we use S3 as a data solution while the training jobs are happening. So, data is securely stored with proper encryption in S3 as a while the trainings is happening.
Great, great. So while registering the model, are you registering the data as well along with that entire sequence of the model?
Uh, so far, some of the models that is being registered, that some of the artifacts are stored in S3, and along
Okay,
with that metadata, we have a custom solutions with that, which is known, which is we have built our like a model registry type of thing, which is along with that Docker images that is created, it also stores the metadata. Okay, what are the parameters that is stored for this model? Is all those things are stored in along with it only.
okay, okay. That's great. So even I think maybe the weights and like there are some new services like weights and biases and these kind of things which actually stores the model hyperparameters. So are you aware like these kind of while training part is these kind of hyperparameters are also getting stored to these kind of cloud services normally, or are we like doing it on the run basically?
Maybe I
Sure,
can
sure,
take them. So
sure.
yeah, so normally what we do is that we do hyperparameter tuning as part of the training. And when we have like a final model, right, which is what we want to implement, so that is the final model that will go to the register. So that will be like a final Docker image and a final model artifacts. Along with that, some metadata we will share, right? So like what is the input that this model takes, what type of model it is, like framework maybe, but we don't share too many details. It's just so that the person who's consuming this model, right? It may not be the same team which produces the model and which consumes the model. So they have some background on how to use the model. In a sense. But we don't like for every run of the training, we don't store all the hyperparameters in this registry. It's only the final model that's generally.
Great, great. Yeah. So basically, that final model is still stored in that, like by giving what is the input prerequisite for that someone else is using that model, we are actually loading it from there and taking it from or on that particular service. Okay, great. And that is actually converted into a service endpoint using these services. Correct. Perfect, perfect. Yeah. That makes a lot of sense. And yeah, so my next question is track to this one. Like, so how are we like once we deploy the model, or like after some time we need to ensure the retraining of the model, or is it automated right now, or like is it happening manually in the process?
So this whole retraining and model life cycle, right? So it's not 100% automated, but we have different components, each of which can be like triggered, right? So we do have some manual steps in the middle just to make sure that there is like a human layer there so that we can, validate the output that's coming to do some kind of double checking, right? So normally what happens is in this diagram, the top diagram is what we call as the model training pipe, the model building pipe, right? So this involves, like Harpreet mentioned, the SageMaker training jobs. So SageMaker training jobs and processing jobs, these are like jobs which you can trigger on demand, right? So you have a piece of code which says, load this data, do this pre-processing steps, uh, train, this model with these hyperparameters. So that kind of a Python script, you can say, is invoked via this SageMaker training or processing jobs. And SageMaker has this idea of pipelines, so where you can combine multiple steps together, right? So you can have like a processing job which just creates the data, then you can have like a training job which trains the model through several hyperparameters, does that experimentation. You can also have like evaluation job which kind of prints out some evaluation metrics, right? So the whole idea is you chain a bunch of these jobs together and create a pipeline. And at the end of the pipeline, what you get is a final model, right? And that model goes into the model registry that we were speaking about, right? So the final model will go into that model registry, and corresponding, model binary files will go into some S3, so that you can see on the right corner there. So that top part is the whole training pipeline. Now the thing is that is, you can think of it as like a separate repository where this whole code is written, and again there is CI/CD attached with that whole process, right? So whenever you get new training data, it will automatically trigger a new training job. You can define it such a way that in a S3 bucket, if you get new data, it will trigger a training job, or whenever you push some new changes to the code base, it will trigger the training job. So these are some ways where you can automatically trigger training jobs. But normally the idea is once you have the training job and the final model from the training job, stored in the registry, you ideally don't want to automatically deploy it, right? Because you do want some kind of approval layer there. So that's why we have this, I think it's number 3 there, which is like manual approval layer. So once that approval, it can be through like an email, or you can even have like a front end or something somewhere where people can go look at the metrics and say click approve. And once the approval happens, that whole model that's created, right, will get deployed as part of the inference pipeline, right? So that's what I spoke about in the first slide, how we containerize the model, how we create inference code and all of that. So that inference pipeline will get deployed, and that is like the second stage of this. Now the model is like live, right? So it's being used, and once it's being used, we also need to like look at the performance of the model, like as it's running live. So we have there are multiple services, like there's model monitoring service. So again, here SageMaker also provides some model monitoring capabilities, or you can build your own on top of that, or even a separate capability which does the model monitoring. So essentially, it will read the data from the real-time APIs. It will also look at, say, maybe the ground truth from some other source of data, because you need to compare the performance in real time. You need both. You need how the model is performing on a given input, and also what was the ground truth, right? And then you can compare that with some standard matrices, like say if it's numerical, you can do RMSE. If it's a classification problem, you can look at accuracy, precision recall, those kind of metrics. And those metrics can be tracked and stored in some so AWS provides like CloudWatch to track these metrics, and you can also set up alarms there. So, for instance, if you feel that performance is dropping beyond a point, right, you could automatically trigger an alarm. And of course, people can go and look at these metrics on a regular basis. So this is like a high level view of how the whole loop is closed. So you have a training loop, and then you have a model deployment loop, and then the model deployment will track matrices, and actually the training data also, right? Some of this data that's published via the model monitoring will feed into the training data as well, right? Because you need some amount of how the model has performed at the time of retraining. So this is overall the loop that is followed, and there are a few places where there is manual intervention, because we do not want to like deploy models right away after they're just trained. We want some eyes on them. So,
Got it, got it. So it's very much structured. I can actually see that, and like I think it's even covering the model drift trigger also. So which is very powerful in terms of like, because most of the times like we deploy a model over the period of time. We sometimes we never monitor the model performance, but this kind of an approach, I would say like it's very much structured in that MLOps side basically, which is really cool. So yeah, so going on to my last point actually. So like, what are the challenges which you guys are actually facing while productionizing these kind of bigger or larger ML toolkits actually?
So yeah, so when we talk about ML challenges, first we have to understand that ML solutions are quite different from the traditional software development we have. It's like most of the sorts of SDLC principles can be adequate, but there are some challenges and some works that need to be worked in a different way for ML solution. So I would like to talk about one of the survey that was done by ML practitioner in the full stack deep learning alumni, which shows that model monitoring, retraining, as well as model maintenance is the most challenging part of the ML lifecycle. So which so which these things solve ML solves a lot of problems, but there are still some challenges which need to be worked on. So if I start with the first one is the model degradation in production, or in a simple language, we can say that predictions becomes less accurate after some time. So it can be due to various reasons such as the drift, environmental change, something new introduced in the system, anything that. So this is where the second thing comes into picture that Lakshmi talked about is that model monitoring. So we need to have a proper model monitoring platform which monitors all the things and compare it to other and set up the proper alerting with that, which so that things will be responsible for retrieving the what we have the retraining pipeline. So when it is requirement, because most of the models are not retrained after once they want to move to production, because but it needs to be retrained at certain times based upon the monitoring setup. So this is another challenge into that. Another problem is around data. So data use for training is somewhat different from the ones that is data which is being served as one. So that causes some solution, that comes with some challenges also. And if I have to talk about infrastructure side challenges, so infrastructure, because ML solutions require a very heavy investment, so infrastructure is another challenge with that. So ML training and deployment both requires GPUs and high density cores. So the cost aspect becomes a challenge. So that is the one thing that needs to be taken into consideration while setting up the whole system. Along with that, the infrastructure need to be properly scaled up based upon the requirement. Like for example, if you have a endpoint which requires a GPU and proper setup, significant endpoint, you have to need to proper scale it when there's a more need and there's more traffic. So that is why where cloud comes into picture, where we can get more solutions into that. And along with that, as I talk about infrastructure as a code, automation is another challenge. So automation needs to be everything need to be automated. It's not like you have a lot of traffic and you manually just set up the infrastructure and all those things. It should automatically scale based on the requirements and those things. Another challenge is that when you have about a lot of models in production, then what do you say? Like a lot of challenges becomes around the model governance and management of this model rises when it is not when we have less models, but when in the cases when we are managing a lot of models. So these things are that. Some other, as I talk about data already, data security and how we have to secure it, because data, uh, for every model, it requires data. So data, it could be there could be various compliance reasons with that. So proper security and privacy of managing of the data is another challenge. So I think, Lakshmi, would you like to add some optimizations or something about while you show?
So I think a couple of more challenges that I can think of, right? So in the last slide, I mentioned about the retraining pipeline, right? So normally, what happens is we have one standard code for retrain. So we look at one framework, say one kind of model framework. We do some kind of hyperparameter tuning, but that's more about it. But usually, when you see it, when you do the initial data science work for a model, you explore many more techniques. Like you might explore fast text, you might explore some Hugging Face transformers, you might explore different algorithms you will explore, and finally zero in on one algorithm, right? But the point is, if you want to automate this process, it's a bit challenging. So you can automate maybe one framework, a training code, but what happens sometimes is, say you retrain after every 6 months, right? So after 6 months, you run the same training code, that the final training code, let's say, you run that on your new data, right? The performance might be as good as what you expect, right, from the business needs. But it's also possible that after a few retraining runs, the performance might degrade, and you'll have to now go and do that whole, from the scratch kind of exploration again. Now you have to try out a bunch of other techniques. You have to try out some more feature engineering into that, data. So you kind of go back to that drawing board. So that will happen for every model at some point in time. So this whole process is not something that we can just plug it and sit back, right? So at some point you will have to like go back to the drawing board. So that's one challenge that happens. And how soon this will happen is also very domain dependent. Some places the data changes very rapidly, in other places it changes more slowly. So there are all those challenges. And also I wanted to add another point to the data challenge that Harpreet is mentioning, right? So a lot of times what happens is the models, the team that builds the model and the place where the model is being consumed, right? They're usually different teams, right? So the model will be incorporated into some specific product, and that product is what is going to generate your training data for the future, right? Now, so the ML team, so to speak, will not have too much control on the nature of the training data. So there could be changes in the data because they would change the schema of their framework, sorry, schema of their application depending on their requirements. So they have other requirements. ML is not the only piece of their whole application, right? Based on their requirements, they can change the schema of the data. So that would have integration challenges in the future when you are trying to. So that data standardization is also another very big challenge in this space. And one way of trying to overcome it is to have like some kind of a data lake. So that's like a layer in between the machine learning and the product team. Right? So product team pushes data, and through the data lake it gets more standardized, and then comes into the model training space. So that's also another challenge that is coming.
Great. So, out of curiosity, one question actually. So, let's say like over the period of time, anyway, like we will be retraining the model with the new set of data. Like, is there like by chance we change that entire model and retrain with another one? Because over the period of time, we may get some new model which is being in the market. So, is there chance like that basically like over the period of maybe like in 6 to 8 months or something like that? Have you noticed something of that sort?
Yeah, that actually has happened in a bunch of use cases. So what happens is we might retrain maybe once in 3 months, right? But after a few runs of this retraining, that the framework that we were using itself has become kind of old, like because this machine learning frameworks are like changing so rapidly. And Hugging
Correct,
Face,
correct.
for instance, in NLP, right? It's every time they're coming up with newer algorithms, they're also updating their existing algorithms. So even if you don't, start with a completely new algorithm, you might want to use the latest version of your older algorithm. So this happens. This is a very fairly common thing. So that going back to the drawing board situation is happens quite